Welcome all to lecture 4. So, today we will be discussing in details about geotechnical investigation, particularly related to soil, rocks. So, myself Dr. Abhishek, and today is lecture 4. So, before going further for today's lecture, we will be just discussing what are the topics we have covered so far in the earlier 3 lectures. So, in the first lecture we talked about the introduction to subsurface exploration, what is the need of subsurface exploration, why we should go for subsurface exploration. Then in lecture 2 we discussed about objectives, what are the objectives of subsurface exploration, and then what are the different classifications of investigation depending upon whether it is a new structure, whether it is an existing structure, whether it is safety of adjoining structure, whether it is about finding suitable material for construction purpose. Then in the last class we discussed about what are the test pits, trial pits, which talks about shallow investigation, preliminary use for small structure, or maybe kind of guiding tool whenever we are going for detailed investigation, like which method to be used, what will be the level of overburden pressure, whether water table is available at shallower depth, so and so forth. Main advantage, as I highlighted earlier, that in majority of the experimental way of collecting the soil sample may be subjected to partial or complete damage or difference due to change in soil structure, mineral composition, moisture content. That is why majority of the time whenever you are collecting sample of soil by means of sampler or the samples you are getting from test pits are mainly considered representative samples or undisturbed samples, which can be used even for consolidation behavior study, which can be used for shear strength parameter determination, so on and so forth. So, that is the benefit if you are going for test pits and trenches, but only limitation is we cannot go for deeper depths, and moreover if the soil is collapsible in nature or cohesionless, we have to provide some kind of lateral support or bracing, which will ensure, like during trenching for deeper comparatively deeper depths, the soil will not fall into the trench. Then we discuss about different kinds of borings, as I mentioned earlier also. So, boring, the principal objective is to proceed a borehole at deeper depth. So, depending upon whatever our design consideration, whatever recommendation from field engineers, we can collect samples, maybe representative or undisturbed sample at different depths. But since the sampling is not being done throughout the depth, so boring is used so that you can advance borehole quickly and reach a desired depth at which you can collect the soil sample. Of course, you have to measure the groundwater table condition as well. And then what are the different kind of samples you generally collect, whether it is representative sample, non-representative sample, undisturbed sample. So, those are the topics we had covered so far. In today's class, we will be discussing, last time when we talked about different kind of samples you collect from borings or sampler, I had highlighted like groundwater table is also an important parameter. But so today in today's class we will be discussing in detail like what is groundwater table determination and why it is important. So, through subsurface properties of soil obtained from specific depth are determined with utmost accuracy, the presence of groundwater table changes its characteristics significantly. So, one is like you are collecting the soil sample from a particular depth, you are determining its strength characteristics, but whether those characteristics will actually play a role or will actually determine the behavior of the foundation, so that will change drastically when we say it is in presence of water, when we say it is in absence of water. So, depending upon whether the soil sample collected from a particular depth, whether that particular depth falls below the groundwater table or it is above the groundwater table. So, accordingly your foundation behavior will change. That is what it means to say, though whatever soil sample we are collecting, we are determining the laboratory test based soil characteristics properly, but if you are not assessing the groundwater table depth properly, it will again lead to some kind of erroneous judgment in foundation design, settlement, bearing capacity and all that. So, the determination of groundwater table is very important as it can affect. So, first one is foundation design, as I mentioned here. So, depending upon whatever is the depth of groundwater table, at times we go for shallow foundation, deep foundation. Also, if it is completely waterlogged area, it will also help you in understanding whether once you go for foundation laying, whether dewatering is required, whether some kind of confinement from the surrounding groundwater table is required or not required, and also what again, as I mentioned, because of the presence of groundwater table, the soil behavior changes. So, whether in the present condition, considering only the soil type, if we are proposing for shallow foundation, whether accounting for shallow groundwater table, that shallow foundation decision will remain sustainable or not, we can it can change with the condition of groundwater table, because the groundwater and its effect on the soil which is available in the zone of influence will finally control the behavior of the foundation. So, that is why presence of groundwater or groundwater table also determines what will be the foundation design. The second one is bearing capacity determination. As I mentioned, the soil in stiff condition or dry condition will behave completely different from the same soil which is partially or fully saturated. So, depending upon how its behavior is, its bearing capacity will change. Because its bearing capacity is changing, so overall the stability of the foundation will change. The third point is settlement calculation. Once the bearing capacity or load settlement curve changes because of the presence or absence of water, that will also get us an idea about what will be a total settlement or differential settlement in actual ground conditions. So, most important is, I mean, as important it is to determine the subsoil properties accurately based on field investigation, based on laboratory investigation, equally important it is to determine groundwater table. So, at times, as I mentioned in the next point, at times boring sometimes people do only for the determination of groundwater table, which may not be available, like if you have some kind of wells available in the nearby location, if you have some kind of lakes, that can possibly give you an indication what is the groundwater table level. But at times if you are not having those kinds of resources in the vicinity of the site, you have to drill a borehole, particularly because you are boring here not for collection of soil samples. So, you can probably go with boring methods and no sampling will be required. So, this will give you what is on an average what is the depth of groundwater table at your vicinity or at the site. For accurate determination, water is allowed to reach equilibrium. It is not like you remove the sampler and then immediately you start observing groundwater table, because it will take some time for groundwater table to get saturated, because you are removing the soil sample. So, I mean, there will be some kind of drawdown in the borehole with respect to the surrounding groundwater table, general groundwater table level. So, in order to ensure that the whatever groundwater table you are reporting in your bore log, it is the equilibrium level, like it is not going to change with respect to the time, maybe after 2 hours, after 3 hours, or maybe after couple of days. If you observe the groundwater table, it may not show significant fluctuation. So, that is why groundwater table determination is only reported once the water reaches an equilibrium, there is no fluctuation going on there. So, the time required to attain this equilibrium again depends upon what kind of soil available at the level where the groundwater table is existing. So, if sandy soil is there, we know the sandy soil permeability is significantly higher. So, the time required for groundwater to reach equilibrium in case of sandy soil, it will be significantly less, because of permeability the pore pressure dissipation will happen too quickly, and then it can reach very quickly to an equilibrium position. On the other hand, if presence of clay you encounter based on borehole report, then you have to wait for maybe few hours, maybe 8 to 10 hours, or maybe more couple of days also, in order to ensure that the water level in the borehole has reached its equilibrium position, and now you can report whatever is the depth of groundwater table in your bore log. So, that will give you proper indication whether it is for sandy soil, whether it is for clay soil, whether the groundwater table has reached equilibrium position. Because if you do not wait for reaching the equilibrium, most of the time it will happen, you will end up in underestimating the groundwater table, like you will report groundwater table at much deeper depth in comparison to what actually is the depth of groundwater in the surrounding region. So, that will again because if you consider the actual groundwater, the soil which is above the groundwater table to be dry, which is actually not the condition, then you are actually overestimating the strength of the material or soil, and same will have effect on bearing capacity and settlement determination. So, overall the effect of groundwater table is important for settlement and bearing capacity determination, and in order to forecast proper bearing capacity and settlement behavior of the soil, you have to ensure the groundwater table, whatever you are determining, it is not going to change. So, once the boring work is over, leaving the borehole for couple of days, like once you have done the boring, you have collected all the soil sample depending upon the depth, you are targeting for 10 meter, 15 meter, 20 meter and more than that. So, what you do, you will leave the borehole for some time, so that the water table in this reaches an equilibrium position. You can observe it rather than going for a separate borehole, which is particularly used for determination of groundwater table level only, because anyway once you are exploring at the site of interest, you are going to drill a borehole. So, what it means to say, you can leave that borehole, but you have to make sure like you make safety measures properly there, and then observe the groundwater table level maybe after couple of days or maybe after couple of hours, because now you are having the soil type available at different depths. So, that will possibly indicate whether you have to wait for couple of days, whether you have to wait for couple of hours for determination of groundwater table. And since you are not drilling a borehole separately, this will be considered significantly inexpensive rather than going for a separate borehole. The presence of groundwater table can be favorable if it is used as a resource for construction purpose. So, if the groundwater table is shallower, you need not bring water from surrounding area or any other resource for construction and for different stages, rather it can be used as a source. But on the other hand, if the groundwater table is too shallow and you are going particularly for deep excavations, then there will be problem, because water will start seeping from the surrounding regions once you start excavating below groundwater table. So, what will do, it will because you have removed the lateral support from the adjacent soil on the face of the excavation. So, along with the water will the soil from the surrounding region, which probably in majority of the times is not the soil belonging to the owner, I mean to the owner of the site. So, what will happen, along with the water, the soil from the adjacent site will also start moving, and slowly there will be a void underneath the foundation of the adjoining structure, which will lead to failure of that structure also. And moreover, it is not only about the stability or safety of the adjoining structure. Finally, the water along with the mixed with the soil, that is slurry, is also getting filled up in your excavated area. That will make difficult for you to continue with your exploration program, or if you are going for laying of foundation, again it will cause difficulty, and it will also compromise the safety, because finally from the surrounding soil there is seepage going on. So, you never know when the entire support will collapse, and there can be minor to major accident can also happen. So, that is why depending upon what is the role water is playing, it can be used as a resource. If you are using it for construction purpose, it can possess danger or difficulty when you are going for underground excavation and construction purpose. Assessment of groundwater table also helps in planning for construction. Like if you know the groundwater table is very shallow, once I am going for actual site exploration or excavation thing, then I will make certain arrangement, whether in terms of providing lateral support, maybe in terms of some kind of confinement, by laying some concrete on the sides as well as the base, which will ensure no seepage of groundwater into your construction area. Or you can go for dewatering or design of lateral support, or as well as you can go for dewatering by means of some kind of pumping. So, whatever water is coming at the side, you pump it out onto on some other again impermeable layer, so that the water can be drained out quickly, at least for time being, when some kind of concrete laying or some exploration work is going on. Because after that, if water again, by the time water table starts gaining its original position, your impervious layer will be there at the site. That will ensure there will not be any further problem because of shallow groundwater table. So, that is a assessment. Once you are assessing this groundwater table well in advance, you can actually be very clear with the planning. You can be very clear whether dewatering is required. You can be very clear whether lateral support is required, and you can go for design of what kind of lateral support is required. For planning of dewatering also, if required, lowering of groundwater table you can do by means of pumping, provided you know groundwater table is very shallow. Another thing, at nowadays we are seeing, like majority of the location, groundwater table is contaminated. It can be because of chemical contaminant, it can be some other impurities also. So, what is the effect of that contaminated groundwater to the soil also, or maybe to the foundation material also? that will also, if you know the groundwater table, if you know the chemical composition of groundwater table, that will help you in understanding or forecasting what will be its impact on foundation stability, and then particularly in case of area where contaminated groundwater table is there. So, once you know those things in advance, you can take suitable measures. So, this was about groundwater table. Last time we discussed about different kind of soil samples. Today we will be discussing about rocks and how you do the sampling and how you make qualitative and quantitative assessment of the information you are getting from rock samples. So, in the subsurface, where the rock comes into picture, because at the site where you are targeting for laying of foundation for construction of a particular kind of project, it is not mandatory everywhere you go you will find only soil throughout the depth of influence. It may be possible you may find some local boulders or gravel, you may find completely hard rock medium after 2 or 3 meter of soil medium, and you may find only rock medium is available throughout the site of interest. So when you go for boring, you have to be aware about what are the ways of collecting sample from soil and what are the ways of collecting sample in rock, and how to examine those samples. So, in case as I mentioned here, in the subsurface medium, in addition to soil, you can have rock layers also, which can be encounters, how to deal with the rock layer, that we are going to discuss. So, before going to how we go for sampling, we should know what are the different kinds of rocks. So, rocks, based on the method of formation, it can be classified as, there are 3 ways, many of us know also, that is igneous rock, sedimentary rock and metamorphic rock. So, how you classify, how you differentiate between each of those rocks. So, igneous rock, these rocks are formed by melting, cooling and crystallization of other rock material. So, whenever there will be some kind of cooling and melting of material resulting in crystallization, depending upon what is the rate at which cooling is happening, it will define whether it is coarse, the crystal will be coarse or it will be small crystals. So, that is called as igneous rock. So, generally formed as a result of volcanic activity. So, whatever material coming out from the base of the volcano, it will come onto the surface, and depending upon the rate of deposition or the rate of cooling, it will become coarse crystal or maybe fine crystal. So, generally resulted from volcanic activity and melting which occurs in the mantle. So, in the molten material is available which will come through the volcanoes onto the surface, it gets deposited. So, those are particularly classified as igneous rock. These are very common, particularly in case of plate boundaries, because along the plate boundary what happen, either 2 plates are moving towards each other. So, there will be some kind of stress developing at the interface which will actually create heat at the interface, resulting in melting of the material at mantle level. On the contrary, you will be having divergent plate boundaries also. So, what will happen, the 2 plates like Indian plate and some other plate which are moving away from each other. So, material from the deeper layer, particularly from the mantle, will start coming onto the surface, it will create new surface. So, those are particularly we are talking about igneous rocks. It will come onto the surface, as you know, in comparison to the below groundwater table, the temperature at the surface is significantly lower. So, it will start cooling. When it will start cooling, then the lava which is coming onto the surface will make igneous rocks. Okay. So, usually crystalline in nature, as I mentioned earlier. So, whenever it is quick cooling, then it will result in smaller crystal. When it is slow cooling, it will result in coarser crystals. So, glassy igneous rocks have no crystals, as these are formed by rapid cooling. So, cooling is so quick, even it does not allow you to go for any kind of crystal formation. Generally, this is about the rocks which are forming by cooling of rocks or molten material by water bodies adjacent to the volcanoes. So, from volcanoes, some molten material comes out onto the surface, it goes to water bodies. So, you can understand when it goes to water bodies, the rate of cooling is so quick, it does not allow any formation of crystals. Example is like glassy rocks. You can see like certain rocks which are very shiny in nature. So, those are igneous rock which are formed by too rapid cooling of molten material. In some rocks, crystal might be formed by a slow cooling process which can be easily visible on the surface. So, the process, particularly when the cooling is happening by means of air, the crystal will be coarser in nature. Example is phaneritic rocks. So it will be much cooler. Then when the cooling itself is quite variable, you can say like for some time it was too quick, for some time it is too less, or maybe certain portion of molten material is exposed to very quick cooling, certain portion is exposed to very slow cooling. It will be a combination of whether it is a crystal, if it is a crystal, whether it is a coarse crystal, whether it is a fine crystal, or there is no crystal at all. So depending upon if some is exposed, some is getting cooled by water body, some is getting cooled by air, again depending upon what temperature of air is available in the surrounding area, it can go for even crystal, coarse crystal or fine crystal. Example given is porphyritic rocks. It has to be highlighted here that about 95% of total crust, the surface medium or the topmost layer of the earth, 95% is composed of igneous rock. So most of the time, because like entire earth is divided into plate boundary, whether it's divided into number of plates, and at the interface of each plate there will be either divergent plate boundary, convergent plate boundary or transform plate boundary. So there is always possibility the material from the either because of the heat generated at the boundary, the material is getting melted and coming onto the surface, or when the two plates are moving away from each other, again it will bring some material onto the surface. And the third one is when the rate of movement along the same plate boundary or the region between two plate boundaries which are moving at different rate of movement, again there will be some kind of slight pass between the plate boundaries, which will also bring some material onto the surface. Possibility is there. So that's why majority of the location, like entire earth is divided into number of plates, and at each plate boundary there are always chances you can have some new material coming up and forming igneous rock. That's why 95% of the earth crust is composed of igneous rocks. Then you go for sedimentary rock, that is second kind of rocks. We know, like depending upon the transporting agency, depending upon the chemical and deposition processes involved, a sedimentary rock can be further classified into 4 categories. But before going into this, we should know like what are the agency which is responsible for weathering and erosion, particularly river, ocean, wind and rain runoff have the ability to carry the particle washed away or eroding the particles from the rocks, parent rock. They will do because of river water, because of oceanic water, because of wind and because of rain. Whenever it comes in contact with any kind of rock layer, what will do, it will actually wash away the material, or by eroding the material or the kind of deposition on the surface and so on. If the process continues for longer time, you can see actually the erosion of material. So these materials are known as detritus, consisting of fragments of rocks, and if the rock is containing of minerals also, so minerals will also be there. When the energy in the transporting, so it's like erosion as well as because of the flow it will be eroding as well as it will be transporting. But over the period of time or over in the longer course, you can see when the energy in the transporting agency, it can be wind, it can be water, it can be rain also. When the energy is not sufficient enough to carry those material to further distances, what will happen? At distant location particularly, the material will actually drop from that flow and will start settling at that particular location. So when the same process happens, these are known as particularly when the transporting agency is not enough strong to bring those material to distant location, it will start processing, and it is particularly the rocks which are formed by this process known as clastic sedimentary rocks. Second one is when material get dissolved in water and chemically precipitates from water or rocks, the sedimentary rock which are formed by such process are known as chemical sedimentary rock. Third one, when living organism extract ions dissolved in water to form shells. So that's why you can see in many of the sedimentary rocks there will be rock formation, in between there will be shells or bones. So this is particularly when living organism extract those ions which are available, and then it will go for some kind of sedimentation over the period of time. Then you call it as biochemical sedimentary rocks. Then next one will be the rocks form including the deposited plants matter. So it's like again depending upon the composition of the rocks. So when the transporting agency is responsible for settling it, you call it as clastic rock. When there is chemical precipitation happening, you call it chemical sedimentary rock. When there will be some kind of, the composition may also contain some kind of plant remains, you call it as organic sedimentary rock. When there is shells and bones because of the presence of organic material organism, the sedimentary rock form, you call it as biochemical sedimentary rock. So these are possibly 4 kinds of ways a sedimentary rock can be formed. Everywhere it's happening like sediment is getting deposited over a period of time, and because of overburden thickness of sediment available at shallower depth, the sediment which is available at deeper depth will get compressed and will form in terms of different stratification or layers. Depending upon the composition, you can go for either it's biochemical, whether it's organic, whether it is chemical, whether it is clastic sedimentary rock. As per a study, more than 80% of rocks which are available at the surface of the earth are sedimentary in nature. So first, when we talk about the crystal medium, which is about the main medium above which you can find majority of the soil location is there, and in between the soil location, whatever rock medium is available, you can find out more than 80% of the rocks which are available. So remember what in the previous, when we were talking about igneous rock, we were telling about 95% of the crust is made of igneous rock. Here we are talking about 80% of the rocks which are available, which may be at the parent position, which may dislocated to some other location. So overall it is different from the crystal medium. 80% of the rocks which are available at the ground surface are mostly sedimentary in nature. Then formation of sedimentary rocks, so you can go with different ways. First one is weathering and erosion, which consists of transformation of solid rocks. So some solid rock is there because of weathering agencies or erosion agency, which can be glacier, it can be ice, it can be flowing water, it can be air also, sometimes it can be gravity also, as we here in case of soil formation also. So depending upon the weathering agencies involved, the parent rock can be fragmented or can be break down into small particles, which may get dissolved by different physical and chemical processes. So this is called as weathering or erosion. Depending upon whether it's because of the flow it's getting dissolved or fragmentation, it will be called as physical process. When because of chemical composition, precipitation it's happening, you call it as chemical weathering. Then transportation. So first we were talking about weathering because of the flow. Then second one is transportation. It may be the same agency which is responsible for weathering, it may be a different agency depending upon relative energy each of those agencies are carrying. So removal, transportation means removal of weathered material by means of natural agencies. Different natural agencies can be there, as I mentioned earlier also. There can be gravity, it can be ice, it can be water, it can be air also, depending upon again relative, like if you go for colder regions, even glacier can also be there. If you go for high altitude region, gravity can also cause, and so on and so forth. So whatever the agency is responsible to bring the material fragments from its parent position to the new position where the material is actually getting settled or deposited, that is known as transportation. So these are different stages. Once it is like erosion or weathering, then the material is getting transported. Then third one is deposition. Once it is transported, then it will start deposition. So sediment is deposited when the energy of the transporting medium, any of the transporting medium which we discussed earlier, becomes too less. Like the agency responsible for transportation is not having sufficient energy to continue with that phase of transportation. So it will start settling the material into that particular location. It may be a nearby location, it can be a distant location also. So it becomes too low or continue the transport process. In other words, when the velocity of transporting medium becomes so less that it cannot compromise with the self weight of the transporting medium material, the material will start settling. It will fall and it will start accumulating. Then there is lithification. Lithification means the process of transformation of sediment deposited at the place into a rock. So what will happen? First of all, there was a parent rock. Because of some weathering agency, there was some kind of fragmentation, there was some kind of erosion happening at the surface, then started transporting by some other agency, then it started deposition. So when the deposition, suppose when the deposition started, it started in small layer, then there will be another layer which is getting deposited, because the material which was getting weathered, it may or may not be available in geological time scale forever. So there will be another material which is getting deposited. So that material will settle above this the layer which was earlier deposited, and same process if it continues, there will be layer after layer deposited one above the other. And considering the load of, so if we talk, if you start with the initial layer which was getting deposited, maybe after several hundred or thousand of years, when more number of layers are there, maybe 20, 30 or so, each of them having different thickness depending upon whether weathering agency were dominating or whether eroding depositional agencies were dominating in that particular geological time scale. So because of the pressure generated, or because of the cell weight of overburden layers, the layer which was deposited initially will start compressing, or which will be transported, which will transform from rock fragments to actual rock formation. So this is called a lithification. So it will start with first layer, then the second layer, then third layer. So finally at the end you will see there will be some sedimentary rock. So there will, because it is called sedimentary because sediments are there which are getting over the geological time scale, it is getting deposited and then consolidated, kind of transformation from rock to sediments to rock, and it is happening layer by layer. That is why it is called a lithification, the process of transformation of sediment deposited at a place into rock. So compaction of material occur at lower depth due to the weight of overlying material. So whatever material was available at deeper depth, it will start compressing because of weight of layers which are available above that particular. So initial it was sediment, and then if you consider that particular sediment is under a very high pressure of overburden layers, it will start forming, or it will start coming in more intact form, that is called as rock formation. This brings the materials together, reducing pore spaces and eliminating some of the contained water. So it will become more and more intact. There will be reduction in pore spaces, there will be elimination of water which is available. So that will improve is, first one, it will reduce the porosity, second one, it will improve the moisture content of the material, and some of the water may contain mineral which once water get precipitated. Okay, so mineral, there will be always water mixed with the minerals. So water, once it goes out, it will precipitate those minerals into the soil, and that soil will transform into the rock. So at the end you will be having some kind of cementing material which will bind up all those sediments together and forming the rock. That will again, depending upon what kind of chemical composition was there in the soil when it was getting deposited, that will define the mineral composition of the last product, that is sedimentary rock. Then we have the metamorphic rock. So when the original rock, whether it is igneous or sedimentary rock, when it is subjected to extreme temperature, extreme pressure, and even extreme change in chemical environment, it will result in change in its mineral composition and as well as its texture from its original rock. Then this process is called as metamorphism, and the rock is called as metamorphic rock. So even initially it was igneous rock or sedimentary rock, but because of some external agency which is responsible for extreme change in temperature, which was not there when the formation of rock happened, whether it is igneous or sedimentary, or pressure which was not there when the actual sedimentary or igneous rock formed, or even chemical environment, that will lead to change in its mineral composition as well as the texture. So the original rock is no more remaining there. This process is called as metamorphism, and that is why the rock is called as metamorphic rock. It can be further classified as foliated rock, where you have layers or bands resulting from extreme heat, or it is like because of quite fluctuation in the heat, the metamorphism is happening at different rates. So that is why you can have rocks formation or metamorphism process happening in terms of layers. So that is why such rocks are called as foliated rocks. Example is gneiss, slate, schist and phyllite. These are the particularly foliated kind of metamorphic rock. And then you are having non-foliated metamorphic rocks, which are formed in the terms of band. It may be having band or it may not be having bands here. So those particularly are called, like example are quartzite and marble. Marble you all see, you do not find any kind of bands or layers in it. So those are called as non-foliated rock. It should be rocks with no bend indication. It should be like no bend indication here. Okay, so that will be like you are. So far we started with a borehole. Then we know like in the borehole you can have soil, you can have rock. So depending upon what kind of rock is available at different depths, before you know that, you should know what are kind of different kinds of rock available. So today we have discussed like a rock means igneous rock, which is particularly because of molten material coming from the volcanoes, or particularly from the mantle layer onto the surface. Depending upon what is the rate of cooling, it can be coarse, it can be fine crystal, igneous rock. Then you have sedimentary rock, depending upon what kind of weathering agency, what kind of deposition agencies are prevailing in the region of your study. There can be more deposition, it can be more erosion in the geological time scale. So same process happening for maybe several thousand of years. So that final deposited sediment will be transformed into the rock because of the chemical which were present in the water. Finally the water get precipitated and the chemical is responsible for binding of those kinds of material and forming the sedimentary rock. Then when such sedimentary rock again in geological time scale is subjected to extreme change in temperature, pressure, or chemical composition, so it will transform from its parent rock, whether it's igneous rock, whether it's sedimentary rock, and the process is called as metamorphism, and the rocks are called as metamorphic rocks. So we have talked about two types of metamorphic rock. The one which is having bands called as foliated metamorphic rock, and the one which is not having bands called as non-foliated metamorphic rock. So this is about the rock. So now you know at different levels there can be possible rock which can be either of the three categories, because again in the present time scale also whatever we see the soil layer, it is also a part of some kind of deposition and erosion. So that's how you see like sometime when there is dust storms also, when there is flow of water particularly during floods or during rainy season. So along with the water, along with the wind, it will take away some kind of material, and on the contrary you may see at certain location that material was not there, but because of the flow of water from that particular place, some material from upper course of the river getting deposited. So that's how you can easily understand. Same thing is you can clearly understand what do you mean by weathering and erosion. Same thing if it continues for geological time scale, it will lead to overall what kind of soil layer which are available at particular location at any site of interest. So now you know what are the weathering agencies, what are the deposition agencies which are responsible for different kinds of rocks available or different kind of soil available in a particular region. Now we go for rock core sampling. So what is rock core sampling? It is a process of collection of rock samples which are available underlying the area of interest by suitable way. Sampling is required so that you can collect the rock which is available at that particular depth, which may not be actually accessible to you in its natural condition. You bring it onto the surface and you characterize the rock in terms of fissures, in terms of cracks, in terms of its strength, in terms of its porosity also. That will define two things. One is what is the medium, what is the characteristic of the medium in relevance to the kind of foundation you are designing in terms of project you are targeting for, and second thing, this porosity, strength, cracks will also define particularly in case of tunnels how suitable is the site for that particular kind of project. And even in case of porosity, if you are using those kinds of rock for some other purpose like for construction purpose, these things will also help you in understanding how suitable this particular material is for any kind of concreting or aggregate use. In case of rock is available near the surface, coring is initiated from the surface. So if this rock is available, that is if outcrop is available or some kind of big area which big boulder is there, you can start the coring from the surface itself. So coring means some suitable way by which you are able to collect the sample of that particular rock. If it is available from the surface, you can start from the surface itself. But it is but in majority of the location you see soil layer available, but certainly after certain depth in majority of the location you find soil layer will be followed by rock layers. So in case rock layer lies at certain depth below the soil layer, so even at the surface you are having soil layer, but you start boring, suddenly you find a rock. If you remember when we were discussing about different kinds of auger, there was rock catcher. So similarly, that you can use it if it is some local gravel kind of thing, but if it is continuously rocky medium, then you have to collect the rock sample, which is not possible by means of that catcher. So you have to go for suitable boring method for initial soil collection or advancing the borehole. Once you reach the layer of rock, then you start collecting the core of that particular row. So coring indicates crushing, dislodging a portion or even sampling of rock from its parent rock. So depending upon whether you required a sample here, you can go for core cutting and bringing out onto the surface, and if you are only interested to know what kind of qualitative assessment, you can go for crushing or dislodging. Dislodging means removal of it by any other means, maybe by chiseling, by means of breaking, so that the material which is coming in between your boring exercise, you can actually remove that material. Once you bring it onto the surface, you will be able to understand better what kind of rock is available, but it will not give you the sample to be tested further in the laboratory. Then depending upon the hardness of the rock to be drilled from the core into suitable drill bits made of different material. If it is very soft, you can go probably with carbide bit. Bit is very much similar to drill rod. At the end of the drill rod there will be some kind of assembly, at the lower end there will be some kind of tooth. So when you start rotating your drill rod, those tooth will actually scratch the material from the periphery of the core, and finally you will get the core sample, which will be contained in the drill bit, inside the drill bit, which are particularly designed for collecting the soil sample, rock sample. So there, depending upon what kind of what is the strength of the rock available or hardness of the rock, you can go with carbide, you can go with steel, you can go with alloy, you can go even with diamond bits also. Of course, as the name suggests, diamond, so that means you can only use it because it's very costly also. So but you can use it in case of very hard like granite medium. You can, where other drill bits may not work, you can go with diamond drill bits for collecting the sample or for coring it. Bits cut the material by means of rotating action. If a lot of drill bits are available on hardware shops also. People who are interested, you can actually go there and find out what kind of drill bits people are supplying. Not a routine hardware shop, but maybe more advanced, where people, particularly the agencies which are responsible for drilling and coring, they can collect it from there. So you have this drill rod which actually goes to the depth at which rock sample is available. Then there will be drill bit which is attached at the bottommost layer. Then you put that drill bit, the tooth face, on the face of the rock. Then you start rotating, so it will scratch from the periphery, and then once the material is scratched, your drill rod will be lowered, and so the same process will be continued for deeper depth. And once you reach desired depth, you will actually bring the material onto the surface. So that's called as core. Sampling of the rock. So you can go for double or single barrel or double tube barrel. It can be used for collecting the rock samples. In drilling operations, sufficient quantity of water will be required, because as the drill bit is rotating, lot of heat will be generated. So in order to ensure that heat is will not cause any problem or hindrance in the operation, and also to minimize the wear and tear of both sample as well as the drill bit. So water will act as a lubricant, and it will reduce the wear and tear of the drill bit. So it can be used, and sufficient quantity of water. So water, you have to continuously flow some kind of water there, which will reduce or control the heat generated at the interface of the drill bit and the rock. And the second one, it will be used as lubricant and reduce the wear and tear of the drill bit. So that's why water will be always circulated through it. In order to circulate the water, there will be single barrel. So in single barrel, from the single the only tube available, water will be passed through the drill bit, and then the same thing will continue. If you are going with double tube barrel, water will be transferred to the one tube, and the inner tube will collect the soil sample, rock sample. So as mentioned here, in double barrel, water comes out of the barrel and split over the rock, because drill is attached to the bottom. So water comes out through this drill bit and spread on to the rock sample. In case of double barrel, water flows out in between the outer and the inner barrel, and the inside barrel will contain the rock sample. So the maximum depth of rock sample what you can actually take out depends upon what is the length of the barrel. we are talking about 2 barrel or 3 barrel. So these barrels will be used at the bottommost layer whenever you are collecting some rock samples. So whatever is the length of the barrel, you can go for that is the maximum length of the core you can actually drill. As I mentioned earlier also, drill bit you can only use, you can use particularly for very hard medium, because if medium is softened, then you can go for other kinds of drill bits which may not be, diamond bit may not be required. Upon reaching desired depth of drilling, the barrel of the will be withdrawn onto the surface and the sample is logged properly. So you are bringing, as I told about soil also, at different depth you will be having different rocks, soils. Same is with the soil. So it's rock. So it's not like whatever soil you are encountering maybe at 5 meter, and after 5 meter till 30 meter if rock is only available, it may not be mandatory like for entire 15 meter you will find same kind of rock. So you have to collect the soil sample, and it may be possible because of the fissures, maybe because of cracks, maybe because of some disturbance caused by mechanical drilling operation, the rock core sample may break in between. So what I mean to say here, whenever you bring or whenever you withdraw the barrel onto the surface, because of the cracks available in its natural condition, or because it was created by drilling operation, entire core will not come. So that's why you have to lower the barrel again and again and bring it onto the surface, and then finally you will lodge it properly. Whatever sample you are collecting, you will lodge it, you will store it properly, what depth you had collected, what was the borehole number, what was the depth from which it is collected, and what time it is collected. So you can see here the core stacking. You can see in this picture, you can see at different depths you had collected rock samples. So on this you will actually write what is the rock type, what is the depth from which it is collected, and drill, date of drilling, when you started drilling, when you collected the soil samples. So you will actually write here rock type 1, and here 2, 3. It may be possible like you are having more, and then I have shown here very intact rock. There may be possibility there will be some kind of cracks here, which will not able to get you entire core sample at one instant, but there will be some kind of broken material in between this because of its natural condition, or it may be because of some kind of drilling operation, some crack had developed on the core. So proper stacking is very important, because finally you will collect those sample and you will get to know what kind of rock is available at different depths. So this rock information along with the soil information will actually give you overall idea, like this is my site of interest. So at this particular layer what kind of soil were there, type of soil, and then type of rocks, and considering this is your entire thing is your zone of influence. So this entire will control your behavior of foundation, whether in terms of bearing capacity, whether in terms of settlement. Okay. Then we had collected the sample of rock, but how you assess whether the sample is good, whether the sample is bad, or so on and so forth. So generally we use rock quality designation. Rock quality designation will give you an indication depending upon the core information what kind of rock is available, whether you can classify rock is very good, whether you can call it as very poor, whether you can call it as fair, excellent, so on and so forth. So this is very important term when you are particularly dealing with rock samples. It's called as rock quality designation. So rock samples obtained from drilling are the indication of the quality of rock and its strength characteristics. It is very much possible that the rock sample you are collected, it may not come in single piece, but is recovered as a segment of small pieces. That's what I told in the rock core stacking. You may get continuous same sample depending upon the length of the barrel, or you may get into pieces, you may get some intact pieces, in between there are smaller boulders. So all possibilities are there once you collect those samples. So how you will get an idea overall what kind of soil is, what kind of how you classify that particular rock. So depending upon its strength, because once you classify, that will give you what is the idea about strength, what is its suitability for a particular kind of material as foundation material, or maybe as construction material. So RQD is rock mass classification factor. So there are different factors based on which you can actually assess the quality or the strength of the rock, which will give you an understanding about how suitable that particular medium in the light of bearing capacity, settlement, construction practice, or even impermeability kind of thing. So possible indication of RQD will also give you possible indication of degree of jointing, fracture in terms of percentage present in the rock core. So whatever rock core you have actually drill out by means of drill bit and barrel, you will RQD will help you in understanding what is the fracture, what is the degree of jointing available. So International Society of Rock Mechanics ISRM in 1981 suggested you can go for rock core of 54.7 mm diameter and 150 centimeter length. That will be the rock core should be used for RQD determination. So how you determine RQD? Suppose you collected some rock sample from a particular site, brought it onto the surface. So you will be having different kind of, this is, you can consider this entire rock core as 150 centimeter is the total length of the core you had actually drilled and brought it onto the surface. Now you can see here, because of mechanical vibration, because of drilling, it was shaking and then it broke this core. But overall this is having some kind of discontinuities or cracks here at different segments, which is actually available in its natural condition below the ground level. So what RQD will tell you, the total length of all cores which are greater than 100 mm or 10 centimeters. So you based on the core stacking at the surface, you can measure actually what is the different length of each of these cores between each kind of natural breaking or discontinuity available. This one we will consider as intact part of the core, because it has happened because of mechanical breaking or drilling operation. It was not there in natural condition. So this entire core will not split into two parts, we will consider as single core or single length of core stick. Now here you consider different lengths are also given here, and starting from the top surface to the bottom. You can see here some are 15 centimeter intact rocks, and then there are 3 centimeter because a small portion of rock came out, then 7 centimeter, 5 centimeter, 26. So this is again, remember this figure is not to the scale, so 36 centimeter and 7 centimeter may not found proportionate to each other, but overall this is the length of the core you are trying to understand. So in order to determine RQD, you will count how many number of cores are there which are having length of 10 centimeter or more than that. You can see here there is 15 centimeter, then 11 centimeter, then 26, 28 and 36 centimeter. So all those are the cores which are greater than 10 centimeter length individually. You sum it up, then divide it with the total length of the core, that is 150 centimeter. That will give you what will be the value of RQD. It says like 77.33% is your RQD of the rock sample. Same you can determine for each and every kind of rock sample rock core you are determining from different depths. So once you know RQD, you can actually classify the rock. So if RQD is varying from 0 to 25, you will say it is very poor rock. So as suggested here also, 0 to 25 means majority of the rock core will consist of a small fragment. So none of them, because it is intact or in smaller longer length, so it will be considered a highly weathered rock kind of thing. Then 25 to 50 you can call it poor, like slightly better, but still the RQD is too less to be call it as good. Then 50 to 70 it will be called as fair, 70 to 90 you call it as good rock, and if it is 90 to 100 you call it excellent rock, considering the foundation material, considering it for bearing capacity or other property determination, because finally it is available beneath the ground surface. So finally your load has to come here. So in order to classify whether it is suitable for any kind of purpose, you have to determine RQD. So as we have calculated here, as per this DER 1964, this can be classified, this core which is shown here, it will be classified as good rock. Same way you can go with total core recovery, that will give you an indication like overall when you started collecting the core from a particular level, what percentage of core actually you can recover, you could recover. To give you an example, like, so this is how you define total core recovery, is like total length of cores, even small pieces, how many cores you could recover. It may be possible you put your barrel for diameter, but you may not find any kind of core, or it's like too weathered rock which may not be available once you brought into the surface. So no core recovered, that will affect what is the total core recovery. So you have different segment, but here in the lowermost segment you say there is no recovery. it is less than, so whatever you have recovered, so this is again called as total length of the core recovered. So what you will do, whatever core you have recovered, if in small pieces, you will sum up here, and then you will determine what will be the total core recovery. So you can say here 66% core has been recovered, this portion cannot be recovered. So you can determine summation of all these parameters, that will give you what is the length of the core which could not be recovered, whether it was too crushed material, too weathered material which cannot be recovered. So it is like 66% is the total core recovery. So this is overall, I mean, today's class, it gives you broader picture. What I try to show here, it's like what are the different kinds of rock which possibly may be available at different medium. It can be sedimentary, it can be igneous, it can be metamorphic also, because agencies, a lot of agencies are involved which are actually governing the processes, helping in overall development or origin of the rocks or transformation of the rocks. And such rocks, when available at different depth, how you collect the sample, how you interpret the sample of the rocks. So in more classes, we will be discussing more interpretation, particularly in case of rocks as well as soil. So this is overall. So that's how you can get an idea, quantitative assessment about whatever core you have recovered. Two important things are there. One is determination of RQD, and second one, as I mentioned here, stacking. Because if you do not do proper stacking, you may find very good RQD, but if you have not reported it properly, you will end up in reporting it at very deeper depth, which may be at lower depth of your zone of influence or outside your zone of influence. So that will not be proper interpretation, that will not be proper use of outcome of in situ investigation. So as important it is to collect the sample, same importance, equally important it is to store it properly, so that you can interpret the data equally. So this is about today's class. Thank you very much.